So we have two inequalities here. The first one says that x plus 2 is less than or equal to 2x. And this one over here in, I guess this light purple mauve color is 3x plus 4 is greater than 5x. Now over here we have four numbers, and what I want to do in this video is test whether any of these four numbers satisfy either of these inequalities. So I encourage you to pause this video and try these numbers out. Does 0 satisfy this inequality? Does it satisfy this one? Does 1 satisfy this one? Does it satisfy that one? So I encourage you to try these four numbers out on these two inequalities. So assuming you have tried that, so let's work through this together. So let's say, so if we try out 0 on this inequality right over here, let's substitute x with 0. So we'll have 0 plus 2 needs to be less than or equal to 2 times 0. Is that true? Well, on the left-hand side, this is 2 needs to be less than or equal to 0. Is that true? Is 2 less than or equal to 0? No, 2 is larger than 0. So this is not going to be true. So this does not satisfy the left-hand side inequality. Let's see if it satisfies the right-hand side inequality, or this inequality right over here. So in order to satisfy it, 3 times 0 plus 4 needs to be greater than 5 times 0. Well, 3 times 0 is just 0. 5 times 0 is 0. So 4 needs to be greater than 0, which is true. So it does satisfy this inequality right over here. So 0 does satisfy this inequality. Now let's try out 1. Let's try out 1. So to satisfy this one, 1 plus 2 needs to be less than or equal to 2. See, 1 plus 2 is 3. Is 3 less than or equal to 2? No, 3 is larger than 2. So this does not satisfy the left-hand inequality. What about the right-hand inequality right over here? So 3 times 1 plus 4 needs to be greater than 5 times 1. So 3 times 1 is 3 plus 4. So 7 needs to be greater than 5. Well, that's true. So both 0 and 1 satisfy 3x plus 4 is greater than 5x. Neither of them satisfy x plus 2 is less than or equal to 2x. Now let's go to the 2. And I know it's getting a little bit unaligned, but I'll just do it all in the same color so you can tell. So let's try out 2 here. So 2 plus 2 needs to be less than or equal to 2 times 2. So 4 needs to be less than or equal to 4. Well, 4 is equal to 4, and it just has to be less than or equal. So this satisfies this inequality. What about the right? What about this purple inequality? So let's see. 3 times 2 plus 4 needs to be greater than 5 times 2. So 3 times 2 is 6 plus 4 is 10, needs to be greater than 10. 10 is equal to 10. It's not greater than 10. So it does not satisfy. It does not satisfy this inequality. If this was a greater than or equal to, then this would have been a greater than or equal to, and it would have satisfied it, but it's not. 10 is not greater than 10. It would satisfy greater than or equal to because 10 is equal to 10. So 2 satisfies the left-hand one, but not the right-hand one. All right, let's try out 5. So 5 over here, 5 plus 2 needs to be less than or equal to 2 times 5. Once again, everywhere we see an x, we replace it with a 5. So 7 needs to be less than or equal to 10, which is absolutely true. 7 is less than 10, so it satisfies less than or equal to. So 5 satisfies this inequality. And what you're probably noticing now is that an inequality can have many numbers that satisfy it. In fact, sometimes they'll have nothing that satisfies it, and sometimes they might have an infinite number of numbers that satisfy it. And you see that right over here. We're just testing out a few numbers, and for this left one, 0 and 1 didn't work, 2 and 5 did work. Now this right one, 0 and 1 worked, 2 didn't work. Let's see what 5 does. So in order for 5 to satisfy it, 3 times x, now x is we're going to try out for 5, we're going to try x being 5, 3 times 5 plus 4 needs to be greater than 5 times 5. 3 times 5 is 15, 15 plus 4 is 19, 19 is to be greater than 25, it is not, So 5 does not satisfy this inequality right over here. So anyway, hopefully you found that fun.